So the last thing that we're learning in this topic is the area of a triangle. So if we have a look at our formula here, this is it. It's area equals a half AB sine C. So I want you to write the word area and not A, because you're going to get it mixed up with the angle A if you do that. So area equals, and we just start with A, B as our little sides and finishes with angle C. It is a sign in here. It can be easy to write cos. I've done it myself when I was at school. I did it right through a test and I'll never do it again. So it does have a sign in it, not a cos. Okay, so area equals a half AB sine C. So if you have a look at the diagram we have here, if that's my little a and that's my little b, my angle C will be here. Okay, because if you think about it, if that's our angle C, this would be side little c here. We're not using the little c, right, but that's where it would be. So what we're actually doing is using two sides and the included angle between those two sides. All right? So we're actually using the angle and the sides around that angle. So let's just try and find these areas. They're all to one decimal place. The first one's just a straight substitution. So our angle is C here, and our little a and little b are around it like that. Of course, you can imagine little c would be here, and we're not using that in the formula. So subbing in, we've got a half times, whoops, I've written them the wrong way around for what I did for the substitution, so I'll just swap them back around to see if I get too mixed up. All right, so I've called A 29 and B 32. So it's a half times A times B times sine 63. It's pretty quick to do in your calculator. So just press your fraction key. 1, down arrow, 2, right arrow out of your fraction, times 29 times 32 times sine 63 and close the bracket. And when you press equals, that's what we end up with. Let's write that down. Okay, and we're going to one decimal place. So if you draw your line here, it's not going to change. It's 413.4 metres squared. We're finding an area. Make sure you've got square units on the end. All right, now the next one's got a little trick in it, so be careful. So when we're doing it, our two sides are A and B, these two numbers here. You can decide which you like, I don't care. Let's just make it like that. And we start our substitution and look what happens. Half times 14 times 19 times. Now, angle C is between the two sides. So if I just go over these two sides with my red pen, the angle we're using, angle C, needs to be there. And we don't have that angle. So does that mean we can't do it? No, because you know how to find that angle. There's 180 degrees in a triangle. So to find this angle in here, we do 180 minus 55 minus 37 and see what we get. If we do that, we're going to end up with 88 degrees, I think. 80, 92, yep, 88 degrees. So that's the angle we're going to be using here. So it's going to be sine. The 88 we just found, so we'll put that in. And now we'll go to our calculator and type it all in. So press your fraction key. 1, down arrow, 2, right arrow out of your fraction. Times 14 times 19 times sine 88, close your bracket, equals, and we get this answer. And we're going to one decimal place, 132.9 millimetres squared for area. All right, now they're all getting a little bit trickier. Just be careful. So this one here looks like we've got no information, but this is an equilateral triangle. So if one side is 15 and they've all been marked as equal, then all the sides are 15. And also, it's an equilateral triangle, so the three angles have to share the 180 degrees in the triangle equally. So each angle is going to be 180 degrees divided by 3, which is 60 degrees each. So if I concentrate just on this part of the diagram, I have this side, I have this side, and I have this angle. So that's what I'm going to use in my formula. So it's a half times 15 times 15 times sine 60 degrees. So let's go to our calculator now. Type it in. Fraction key 1 down arrow 2 right arrow times 15 times 15 times sine 60. Close the bracket equals, and we get this answer. All right, and we're going to 1 decimal place. So if we draw it in there, the 2's less than 5. So we stay at 97.4 metres squared for area. Okay, next question. Now, we're getting into composite shapes here. So this is actually a kite. It's got one pair of adjacent sides equal, and here's the second pair of adjacent sides equal. So I'm going to get my red pen and draw a dotted line down the middle there, and I'm going to find one area, that one, okay? So I'm just going to concentrate on that area there for the area of a triangle, the top area. Now it looks like I don't have an angle between my two sides, but I do, because I know this is a kite, and a kite has one axis of symmetry. So if this is 100 degrees, that's going to be 100 degrees up there. Okay, so we're ready to use the two sides and the angle between them to get that area at the top. So it's a half times 10 times 25 times sine 100 degrees. Now we're going to our calculator. Type it all in. Fraction key 1 down arrow 2 right arrow times 10 times 25 times sine 100. Close the bracket equals, and we get this. Now don't round it. We haven't finished. That's just the area of the top. Don't remove this, leave that on the calculator. But these two areas of the two triangles will be identical because this is an axis of symmetry. So that top area and the bottom area will be mirror reflections of each other. Their areas will be the same. So we're going to take that 123 answer we got just then, times by 2, because those two triangles will be the same. So you've still got that answer there. Just press times 2 equals, and that's what it'll give you. Write it down. Okay, and then at the final line, that's when you can round off to 1 decimal place. And it'll be 0.2, and we're in centimetres squared. Okay, next question, E. Now, in this one, we have already got it split into two parts. They've already drawn in a dotted line. So we're going to concentrate on the bottom triangle first. All right, so this is the first one we're going to do, area 1. Now that's a right angle triangle. So I'm going to just use the formula half base by height. It's a lot quicker, a lot less messy, and it's a right angle triangle with a right angle here to show you where your base and your perpendicular height coming away from your base is. Okay, so we have a half times, the base is 12, times the perpendicular height, look for the right angle, coming off your base is 5. Now you put that in your calculator and work it out, and that will turn out to be 30. So that's the bottom area done. So now we're going to do the top area, area number 2. And for this one, it's not a right angle triangle, so we are going to use the formula we learnt today. So we need two sides and the angle between them. So we do have this side, and we have an angle, so we really need this side to be able to do this area up here. Now, do we have that side? No, but we can find it. And those of you who know your Pythagorean triads should be able to tell me what that side is. If you know it, it's the 5, 12, 13 Pythagorean triad. And because they've already given you the 5 and the 12, it's the 13 that's the missing side, right? So you can do it with your Pythagorean triads. If you don't know your triad, you will have to go through Pythagoras' theorem to find your hypotenuse C by putting in your 5 squared and 12 squared. If you continue, you will get the 13 out eventually. So I'm going to put this in now. I'm doing a half. This is the top area times 15 times, now the red one that we just found with the Pythagorean triad was 13 times sine 50 degrees. Now we go to our calculator and put all of that in. So fraction key, 1 down arrow, 2 right arrow, times 15 times 13 times sine 50, close the bracket, equals, and it gives you this, no rounding yet. Keep it on your calculator, because we'll probably need it again. Right, now we're totaling our areas, so we have to add these two areas up. So I've already got this on my calculator, so I'm just going to keep that written first. And I have to add on the 30 I got down here. And, well, you could probably add this up yourself, but if you want to use your calculator, all you've got to do is type plus 30 equals now, and it'll give you this. And then we're rounding off to 1 decimal place like we did with the others. So because this is an 8, we're going to go up by 1 to become a 7 here. So it's 104.7 metres squared. All right, now we're doing F, which is this shape. Now, it is a hexagon. It's got 6 sides. That's all a hexagon is. This is a regular hexagon because it's got 6 equal sides. Okay, so they've all been marked as equal as well. You can see the equal markings. And inside here, you can see that one triangle's been shown to you to actually be an equilateral triangle. So if I want to find the area of this hexagon, I'm going to concentrate on the area of just this one triangle here. So we've been given a side length of 6 for the hexagon, so I can write that side length up there with my red pen. And it's an equilateral triangle, so all the angles are going to be 60 degrees each. So we've got 6's for all the sides and 60 degrees for all the angles. So if I just focus on this angle here and say, okay, I know that's 60 degrees because all equilateral triangles will have 60, 60 and 60 to make up their 180. And these are all equal sides. So that's what I'm putting in my formula. A half times 6 times 6 times sine 60 degrees. So we're going to get our answer without any rounding and see what we end up with. Okay, fraction key, 1 down arrow, 2 right arrow out of it, times 6 times sine 60, close your bracket, equals, and this is what you get. No rounding yet, because we haven't finished. Okay, now, keep it on your calculator. We found the area of one little triangle. How many little triangles are in here? There's 6. So we're going to get that area of one triangle and times it by 6 triangles. And I'm going to do this on my calculator now. So I've already got that answer sitting there from before. So now I'm going to times by 6 times 6 equals, and that's what we get. Write it down. And now we're rounding off to 1 decimal place at the end here now. So that's a 3, so this will stay as a 5. So our answer is 93.5 centimetres squared. Okay, now this last question is one that they often will ask, just to see who really understands how to go from one thing to another in maths, combining all the work that you should already know because you've done lots of practice on it all. Okay, now a segment. It says find the area of the shaded segment. Okay, they've shaded it for you so you can see what we're talking about here. It's this bit up here. That's what a segment looks like. It's just a slice off the edge of the circle. This is called an arc, and this is called a chord. So it's bounded, surrounded by an arc and a chord, and the area in there is a segment. Okay, now to do it, you actually have to find the area of this whole sector. Now a sector's like a piece of pie, all right? So it's this bit we're looking at the moment. That's what we're looking at for a sector. So we need to find what angle we're using in there, which they've given you, 120 degrees, and find what fraction of the circle that's taking up. So, well, it's taking up 120 degrees out of 360 degrees, right? So this is a formula for the area of the sector. And if you forget it, it should make sense anyway. Now, we're finding the area of this. So we want, what fraction is it of the area of the whole circle? So we're timesing by pi to r squared. Our radius for our circle is 15. And now we're going to put all of that in our calculator. So just type it in your calculator, fraction key, 120 over 360, right arrow out of your fraction, times pi. Now remember on your calculator we're pressing, shift, and there's your pi key down the bottom here on the yellow one, so shift pi, times 15 squared equals, and here is your answer for that section, or that sector. Okay, the next thing we need to do is find the area of this triangle here, the actual triangle. Okay, so we're going to find the area just of the triangle piece, looks like that. We've got the 120 in there, and you've got two radiuses either side of it. They've both been marked as equal, so we know that's 15, and that's equal to it, so that's 15 as well. So it's a straight out subbing in of your formula here. Half times 15 times 15 times sine 120 degrees. So you can go straight to your calculator for that part. So we're typing in the calculator. Fraction key, 1 over 2, right arrow out of your fraction, times 15 times 15 times sine 120, close the bracket, equals, and it gives you this. Now, the little segment at the top there. So what you've got is the whole sector, and then you're going to find, if we found the area of the triangle, you're going to cut that area of the triangle off and throw it away, and that'll leave you with what you want. All right, so what we're actually doing here is we're taking the sector, the whole piece of pie, we're going to take off the triangle, and that will leave us with the little segments that they're actually wanting us to find the area for. So let's do that subtraction. Now I've still got that on the screen from before. So watch what I do. We want to subtract that number. So we're going to start with 235.619449. Right? Then we're going to press minus. Then we want to minus the answer we had a minute ago. Answer equals, and there it is. Now, this question has not asked for any rounding, so I'm not going to give any. I'm writing just the whole answer down. It's in centimetres squared because it is an area. Okay, so there's been a few tricky questions in that. It's a fairly simple formula. So you do need to practice this work and so that we don't get it mixed up with the other work we've done so far. So the topic is now finished. The rest of what we're doing now is revision. So if you've been keeping on top of all your work, this is just now consolidation. All right, so good luck with the homework. Make sure you practice it.